Ramanujan for G is now available on the Google Play Store. Try it out for free.
Morning, everyone. So today, in the binomial theorem, we'll see some more examples. Okay, then we'll start the topic binomial theorem for any index. Okay, so first we'll see some examples. Okay, so let me write the question for it. Question is given if C naught, C1, C2 up to Cn are binomial coefficient, then then C naught plus C1 by 2 plus C2 by 3 and Cn by Cn plus 1 equals. Okay. So here what you have to do, first write this expanded formula 1 plus x to the power n. This C naught C1x plus C2x square and goes up to Cn xn. Okay. Now integrate with respect to x, right? Integrate with respect to x. Okay, so here you will get 1 plus xn minus 1 and plus 1 c naught x plus c1 x square by 2 plus c2 x cube by 3, and this goes on up to cn x to the power n plus 1 n plus 1 plus of k. Okay, now put here x is equals to 0 and k is equals to 1 upon n plus of 1. So you will get C naught plus C1 by 2, C2 by 3 goes up to Cn by n plus of 1. So that you can write it as 2 to the power n plus 1 minus 1 minus of 1 divided by n plus of 1. So this is your answer. So you can note down this problem first. Next thing, we'll take one more problem based on this. Okay, so next problem is given question. If C0, C1, and C2, Cn are binomial coefficients, then 1 upon n factorial 0 factorial plus 1 upon n minus 1 factorial plus 1 upon n minus 2 factorial, and this goes up to 0 factorial n factorial, which is equals to what? Which is equals to what? Okay, so in this, solve this problem. So we'll write C0 plus C1 plus C2 and goes up to Cn, which is for the 2 to the power n. So here n factorial, n minus 1 factorial plus n factorial, n minus of 1 factorial, 1 factorial, n factorial, n minus 1 factorial, 2 factorial plus goes up to n factorial by 0 factorial, n factorial. So that becomes 2 to the power n, n factorial. Okay, so this will become your answer. Okay, just note down this problem also. Okay, so now let's start the next topic, which is binomial theorem for any index. Okay, so let me write it here. Binomial theorem for any index. Okay, so here if we talk about when n is a negative integer or fractions, then expansion of binomial is possible. First, the condition is negative or fraction integer. Talking about n. Okay, so here we conclude first term is 1, first term is 1, and second term is numerically less than 1. Okay, so x is less than 1, so here we can write 1 plus x to the power n. So here we write 1 plus nx plus n of n minus of 1 by 2 factorial x square n into n minus of 1 n minus 2 by 3 factorial x cube, and this goes up to n into n minus of 1 plus 1 divided by r factorial, and here x to the power r, and this goes up to infinity. Okay, so here if we talk about its general term for this, so it becomes tr plus 1, so that is n into n minus of 1 n minus of 2, and goes up to n minus r plus 1 divided by r factorial into x to the power r. Okay, so just note down this. Okay, so now here we can write the expansions. Okay, so we'll start with the right for the 1 minus x power minus 1. So that becomes 1 plus x square plus x cube, and this goes up to x to the power r. So its general term will become tr plus 1, which is x to the power r. Okay. Now if you go for 1 plus x to the power minus 1, then so 1 minus x plus x square minus x cube, and this goes up to minus x to the power r plus. So it's a general term tr plus 1. Tr plus 1 will become minus x to the power r. Next is like if we go for 1 minus x power minus 3, then it becomes 1 plus 3x 6x square plus 10x cube, and this goes on, and final term r plus 1 r plus 2 by 2 factorial x to the power r, and plus goes on. So general term will be r plus 1 r plus 2 divided by 2 factorial x to the power r. Next is 1 plus x power minus 3, so that becomes 1 minus 3x plus 6x square minus 10x cube plus goes up to r plus 1 r plus 2 divided by 2 factorial minus x to the power r, and general term will become r plus 1 r plus 2 divided by 2 factorial, and here minus x to the power r. Okay, so just note down this, then we'll look out at examples. Okay, so let's solve few examples. Question is given, the term independent of x in expansion of 1 minus x 1 plus x whole square is. Okay, so solving this, 1 minus x square multiply with 1 plus x to the power minus 2. Okay, so this becomes 1 minus 2x plus x square 1 minus 2x plus 3x square, and this goes on. So the term independent of x is 1. Okay, let's solve one more problem. If x is less than mod x is less than 2 by 3, then fourth term in expansion of 1 plus 3 by 2x power half is. Okay, so let's solve. So t4 is half minus of 1, again half minus of 2, and divided by 3 factorial, and multiply with 3x by 2 whole cube. So that becomes 27 by 128 x cube. So this is your answer. So with this, we are going to wind up the lecture here. Okay, so thank you guys. See you in the next lecture.